I have a little demonstration you can do, or experiment students can do, where they can show how radio waves can be produced by a simple electromagnetic induction. What I have is a coil, and in the coil, which is wrapped around a regular bathroom roll, are about 100 turns of number 22, 24 copper wire. It doesn't really matter. This is insulated copper wire, and so the ends have been stripped. Use the sharp part of a scissors and scrape it. I've connected one side of the coil with a little clothespin and a little aluminum foil attached to a wire. It makes an easy connector. To a couple of D cells in series, and then connected the other side of the D cell to a file. So if I turn on my radio, every time the conductor touches one of the parts of the file, creates a little spark, and that spark creates a radio wave because it emanates from this electromagnet here. As the magnetic field increases and decreases, it creates a little back EMF, and the EMF creates the spark, and you hear that on the radio. You can also use something as simple as copper wire wrapped around a bolt. Here again we have a small amount of electromagnetic field created, spark generated because of the back EMF, and you hear that spark, you hear that radio frequency generated from that spark across the radio frequency. In this example, I've replaced the file and the electromagnets with a motor. This is a small little DC motor, and inside the motor is a set of coil wires that are attached to a commutator. Every time the commutator attaches electrical contact to the armature, it's an electromagnet which interacts with the fixed magnets. That causes a little bit of spark every time the current goes through the armature on the commutator. So the spark is another way of generating a field, an electromagnetic field, which creates both an electromagnetic and radio frequency. So again, I can turn on our radio. And this surprisingly has an impact on the radio at quite a distance.